So, this is going to be your first little mini lesson of physics. Today we're talking about learning objective 1-1. And I want to just take a quick second to introduce you to these learning objectives and how you're going to be using these videos in order to help you. So basically, each learning objective in this class is going to have a quick little note section that you're going to be filling out on Notability. You'll watch these videos and then you'll go back and add in the information that I'm giving you about each learning objective. Our first learning objective, LO1-1, is about writing a procedure. So you can see right here, it says write and carry out a procedure, specifically explaining how the independent variable will be changed and how the dependent variable will be measured. After you've watched this video and you've filled out all of the notes, when you get to class, right at the beginning of class, you're going to be taking a quiz on this. And hopefully you're going to do really, really well. But if you don't, that's okay. This is a learning experience. The goal is not to see who can get the perfect score the first time. The goal is to watch the lesson, take the quiz, and if you make some mistakes, learn from those mistakes and do better the next time. You have an opportunity to get a little bit more practice after the quiz. You can do a little review after the quiz, and then you can retake it. So I really want to focus on that growth. You're watching the lesson now, you're going to take the quiz, and you've got to be willing to make some mistakes. If you fail on the quiz, that's totally fine. That is not a final thing. That is not really failure. All right, so we're going to dive into this and start filling it out. So we're looking at this idea of designing an experiment. When we're designing an experiment, the first thing we need to do is we need to begin with understanding the apparatus. This is our apparatus for the Spaghetti Bridges lab. We've got some spaghetti, we've got a cup, we've got some pennies in the cup, and we've got this sort of gap that it's all spanning. Once we understand what the apparatus is, we're now going to think about what could be changed or measured about the apparatus. Those things that can be changed or measured are called variables. I'm just going to go ahead and select my pen, and I'm going to select one of the dots in this top row up here. Those are best for writing, and I'm just going to fill this in, and I'm going to go variables right here. Okay, so these are some variables that we could look at in the Spaghetti Bridges lab. We could look at gap width, we could look at, and that would be measured in centimeters. We can look at number of pennies or mass, which would be measured in number of pennies, or mass would be measured in grams. We can look at number of noodles. We can look at centimeters of string length. We could look at centimeters of height off the ground. We have lots and lots of options. When we're thinking about all the different variables, we then need to think about which of those variables count, because not all variables are created equal. So only variables that are quantitative and quantitative means that they can be represented with a number. Only those variables count, okay? In other words, those things must be measurable. Okay, so in physics, if we cannot measure a variable with a number, then we are not going to include it in an experiment. In this case, all of those variables, gap width, penny number or mass, number of noodles, string length, height off the ground, all of those variables are quantitative, and so they would all count. However, we could imagine a situation where we had another variable, something like this doesn't work for this experiment, but something like happiness. Happiness is not a quantitative variable because it's not something that can be measured with a number. And so we're not going to count that. In fact, I'm totally going to erase it off my list of variables. Okay? Now that we know which variables count, now that we have only quantitative variables, we now need to think about the two types of variables, independent variables and dependent variables. Remember that independent variable was up here in the learning objective, and so that's an important thing for us to know in this lesson. I'm going to highlight all independent variables blue to match the way I highlighted the word independent variables on this slide. So independent variables are the things that you can directly change from one trial to the next. They're independent, which means you can directly change them. They don't depend on some other variable. So let's think about this. Looking at our list of variables, which of these can I directly change? I can set the value each time. Well, I can directly change the gap width. I determine how big the gap is. It is an independent variable. I can also directly change the number of noodles. Okay, because I can add more or I can subtract more. I can also directly change the string length. I can add more or I can subtract more. Those are all possible independent variables. Now, number of pennies is not actually an independent variable because the number of pennies is actually the number of pennies it takes for the spaghetti to break. And I don't control directly whether the spaghetti breaks at 5 or 10 or 15 centimeters. If I want to make the spaghetti hold more pennies, I have to actually change something else, like maybe I have to add more spaghetti, and then the number of pennies changes. But you see that the strength of the bridge is not something I directly control. It depends on something else. So therefore, the number of pennies, or the strength of the bridge, is a dependent variable. This is the one you can't change unless you change something else. It depends on another variable in the experiment. A dependent variable is something that you measure to look for a change. You're basically trying to figure out, do the changes in the independent variable create a change in the dependent variable? I'm going to highlight our dependent variable green. So in this case, number of pennies is a dependent variable. You could change the number of noodles, and it might change the number of pennies that it can hold. You can change the length of the string, and it might change the number of pennies it holds. Because number of pennies is dependent on something else, it is the dependent variable. Let's go back a second and talk in a little bit more detail about independent variables. Again, I'm going to highlight this blue right here. Once you've chosen your independent variable, the next thing that you need to do is you need to decide on 5 values for the independent variable. It could be 6, it could be 8, but 5 is the number that we focus on. You don't want to do too few values because when you go to graph your data, if you were to draw a quick graph with like only 2 data points, that's always going to look like a straight line. So it's not very good data because what if the next point is there? Well, that's actually a curve. And even then, if I got 2 more data points, maybe it's even more complicated. Maybe it is a line. I don't know. The only way to get a really good idea of the shape of a relationship is to have 5 data points. Another important thing about independent variables is that the 5th value, so if you have your 5 values, the 5th value should be 5 times the value of the first one. So I'm going to give you an example down here, and I want you to fill this in on yours also. So imagine that the gap here is my independent variable, and the gap is 2 centimeters. Well then, if that's my smallest value, my largest value should be 5 times that. 5 times 2 is 10 centimeters. This rule is really handy for making sure that you test a wide range of values. Sometimes people will test 1 centimeter, 2 centimeter, 3, 4, and 5 centimeters. but they'll forget to go high enough up. And that can really affect what your relationship looks like. So again, up here we have example. If you choose 2 centimeters as the width, then the largest would need to be at least, 10 centimeters. Wrote the wrong thing. Okay. So when we're writing our procedure, when we talk about the independent variable, there are 3 things we need to do. And I've got a little example procedure right here, and we're going to highlight that this person is doing those things. So first, highlighted in pink, it says state the independent variable. Well, this person says the IV will be the width of the gap. So I'm going to highlight that in pink. Next, it says to state how you will measure the changes in the independent variable. And I'm going to highlight that in brown. So we're going to measure the gap from the edge of the table in centimeters. Notice I used the unit and I gave a little more detail about how it would be measured. And then lastly, in orange, I'm going to highlight that it says you should state the values that you will use. So in this case, we're going to use 10, 4, 6, 8, and 10 centimeters. This is full credit on a procedure when describing an independent variable. When talking about a dependent variable, you have to decide how you will measure your dependent variable, and specifically, what tool will you use? I'm going to highlight those 2 important facts, the name and this question, what tool will you use, in green, because that's our little color code for dependent variables. When we're writing our procedure, the first thing we need to do is state the dependent variable. So in this case, they said the dependent variable is the strength of the bridge. Then we're going to describe what tool you'll use to measure it. So this will be measured by adding pennies to the cup until the noodles break. And lastly, we must describe how it will be measured. In this case, we said as pennies are added, we will count them and record the total. So that is full credit on a procedure for describing the dependent variable. The last thing we need to talk about in this is constants. All the variables that were listed at the beginning of your experiment, other than the independent variable and dependent variable that you chose, become constants. Write that in red, because red is going to be my color for constants. And these constants must be kept the same for each trial. So let's use this example here. I've got variables all listed out here. My independent variable was the gap width right here. My dependent variable was the number of pennies right there. And so these values right here, I should actually highlight them, I take that back. These values right here, highlighted in red, become constants. We do not want to change the number of noodles. We do not want to change the string length. When we're talking about constants in our procedure, it's important to think about constants that would have a big effect if they were changed, and also to think about constants that could be easily forgotten. Some constants wouldn't have a big effect, or they are really obvious. And so we don't necessarily need to talk about them. For example, I don't need to talk about making sure the color of the cup stays the same, because it's not reasonable to expect that the color of the cup would actually make a change. Similarly, I probably don't need to worry about accidentally using the wrong brand of spaghetti, because I probably only have one brand of spaghetti to experiment with in the first place. If I have 10 different brands sitting in front of me, that might be an issue, but it's usually not. Instead, I want to think about those ones with a big effect or that could be easily forgotten. That's what needs to go in my procedure. The first thing I'm going to do is I'm going to list any constants that include that. In this experiment, the number of spaghetti would be a huge constant. If you don't use exactly the same number of spaghetti, you're going to have big changes in your results, and it actually could be easy to forget because you're breaking your spaghetti every single time, and you have to make sure you set it up with the exact same number. And the last thing we're going to do is we're going to state the actual value that it will be held at, because that value makes a difference. I'm going to get different results if my bridge is 8 spaghetti versus 4 versus 50. And so we want to make sure to specify what the value will be. If you do those things, describing your constants, your independent variables, and your dependent variables well in a procedure, then you're doing a great job of meeting